Bueno, ingenieros, bienvenidos y buenas noches a los que ya se encuentran conectados. Vamos a iniciar con nuestra clase del día de hoy. Recuerden que les había pedido que tuvieran estudiado el módulo 12, conceptos de W. Pues cuento con que eso ya lo tienen estudiado para el día de hoy. Listo, vamos a arrancar y vamos a empezar con la visualización. Vamos a arrancar en nuestro capítulo o en nuestro módulo 13, configuración de una red inalámbrica. Mirar el video que nos trae la neta acá.
Hello everyone, it's time to get our computer hooked up to a network. In this video we're going to do a wired and wireless configuration using our Cisco wireless router. To start, we will connect our computer's Ethernet port using a network cable to one of our LAN ports on the back. I can take my computer's Ethernet cable and plug it into one of our LAN ports. Next, we want to get this wireless router connected to the internet. So I'll take my internet cable from my modem and plug that into my WAN port on the back. At this time, I can go to my computer's web browser and I can type in the IP address of my Cisco wireless router. If you do not know the default IP address of your wireless router, you can look it up in the documentation that came with it. Or you can use some command line tools on your user device. My wireless router has the default IP address of 192.168.1.1. I'll type it in and I'll click enter. Immediately, my wireless router asks for credentials. I will use the credentials I found in my documentation, which was a username of Cisco and a password of Cisco. Consult your documentation to find your credentials. I'll click on Login. Immediately now, I can't do any configuration changes except to change the default password. The old password was Cisco, as we mentioned. I can see that there's some minimum requirements I need to follow, as well as a password strength meter down below. The password strength meter is not foolproof, but it does help you in determining password complexity. For the new password, I can type in something a little more complex than before, and I can get a password strength supposedly of strong. But again, how much do you trust these meters? They help though. With the new password selected, I'll click Save. And I know it's going to work because it's going to log me out of my wireless router and require me to log back in with my new credentials. I'll use the username of Cisco and then my new password, and then I can click Login. And now we can actually configure our firewall router settings. To get started, we're going to take a look at the WAN settings. That's going to be inside of our networking section, and by default, we're in WAN. We can see that the internet connection type is using DHCP for our internet addressing. Also, for our DNS addressing, we have that set to automatically get that as well from our ISP, our internet service provider. If we wanted to change this to utilize a static address, we could do so. If we wanted to change our DNS servers that we're utilizing to not be from our ISP, but maybe from Cisco's OpenDNS or other servers, we could also select that here as well. Besides our WAN settings, we can go over to the LAN settings, and in our local area network settings, we can see a lot of items that we can configure. To start off here, what we can see is the local address of our wireless router. This is the default address provided by the manufacturer of my router. If I'd like to, I can put in a new value here and then click Save. Besides just changing the IP address on my wireless router itself, we can change the subnet mask, which controls the network size. Also, we have DHCP server settings. By default, my wireless router is acting as my DHCP server. Down below the DHCP server settings, we can see the starting address that we're giving out to the user devices, as well as how many user devices we're supporting with DHCP. The default on my router here is 50 devices. If I'd like to have more devices on my local area network, I can increase this number from 50 to a higher value, for example, maybe 100. As we continue on looking at our settings, what we'd like to take a look at here is, what if I didn't need the DHCP server on this router? What if I had a separate server running on my network? I could use my disable radial button to actually turn off DHCP on this device. When we talk about DNS settings, right now we're getting our DNS utilizing our WAN port and receiving it from our ISP. If I wanted to change what DNS server my users on my network are using, I can use the drop-down menu here for DNS, and I can have it used as below, where I get to specify multiple DNS servers for my user devices to target. So this has been great and awesome so far, but what we want to do now is take a look at our wireless settings. I'm going to go ahead and click on wireless on the left side. I'm not going to save my changes. And our wireless screen loads up. Now inside of the wireless settings, one of the first things we'll take a look at is this enable checkbox. This says our wireless transmitter is turned on and wireless is running on this device. If you wanted to disable wireless on your device, you can uncheck that radial button and it effectively makes our wireless router firewall just a router firewall. This will disable the wireless transmitter. This would come in handy if you want this to act as a router, then you have other devices on your network that are acting as wireless access points to provide wireless coverage for your enterprise network. For us, we want to keep the wireless on so we can continue with this video. Next, in the wireless network mode drop-down box, we can select which wireless to support. If we leave the default of BGN mixed, it's going to be a slower wireless network than going with GN mixed, or G only or N only. For myself, I like to do GN mixed. I'm not going to provide legacy support for wireless B. Below that, we need to take a look at the wireless channel. We can leave this at the default of automatic, where the wireless router will determine automatically the best wireless frequency to utilize to avoid interference. If you wanted to statically set your radio frequency to use, we could do that here as well, but we'll leave it at auto. Down below, I have multiple wireless networks. I can deploy these on the wireless router all at the same time. By using the variety of edit buttons down below, I can change the wireless SSID, I can change the wireless password, I can even change the type of security for our wireless, as well as the maximum amount of wireless clients per wireless network I'm deploying. For example, if I click on the checkbox for the first wireless network of Cisco SB1, I could then click on the edit button down below. Immediately, I can change the wireless network name. Right now it's Cisco SB1. I can change this to Business Connect. Do I want the wireless name of Business Connect to be seen and visible by everybody? I can control that with the SSID broadcast button. Also on the far right, we can even control the maximum amount of clients allowed to connect, which I can change this to, for example, 40. When I'm done with these settings, I will click Save, and my wireless router is going to change Cisco SB1 to now be the name of Business Connect. Also, I'll be allowed to have 40 wireless users connected at a time. Next, if I select the checkbox for that wireless network again, and then I'll click on Edit Security Mode, it'll take me to a new screen. And in Security Mode, I can see my wireless name that I've configured, followed by the Security Mode dropdown. Right now, by default, we have WPA2 Personal. This uses the encryption of AES. This is more secure than choosing something like WPA2 Personal Mixed, which utilizes AES encryption and the legacy TKIP for backward compatibility. For us, we want the security mode of WPA2 Personal with AES encryption, which is more secure, and we will set up our password here. For example, how about this? Awesome. If you want to see what it looks like, that's my password. Now I'll click Save, and this will create the wireless password that my users will need to type in order to access the wireless name of Business Connect. With the wireless network named and our wireless password created, I go to my computer's wireless settings, and I can see Business Connect is ready to be connected to. I can click on that, click Connect, and I can put in that password, and once I hit Next, we should get a wireless network connection. and we are good to go. We are seen as connected. We are accessing the radio frequency being sent off by my wireless transmitter on this wireless router. Now that we've completed this wired and wireless config walkthrough video, make sure you take the time to explore your own wireless router and try your hand at deploying a computer network. Thanks for watching.
¿Alguna pregunta hasta ahí? Bueno, ok. NAT para IPv4. Todo esto de aquí ya, pues, configuración inalámbrica, todo esto ya lo vimos. Esto va a depender del router inalámbrico, del access point inalámbrico que estemos trabajando. NAT para IPv4. El NAT para IPv4, cuando digo lo vimos es en el video. El NAT para IPv4 es una característica que tienen la mayoría de los routers pequeños para Small Office y Home Office en esta presentación que tenemos aquí, porque el NAT es algo que podemos hacer en IPv4 con cualquier router decente, podemos hacer NAT. Pero en este caso, este NAT para IPv4, ¿cómo lo hacemos en estos routers? ¿O para qué lo utilizamos? Generalmente nosotros utilizamos el NAT para IPv4 con el objetivo de hacer un procedimiento que le conocemos comúnmente como abrir los puertos. ¿Qué quiere decir esto? ¿O a qué hace referencia? Hace referencia básicamente a que nosotros, a que nosotros queremos permitir que al apuntar a nuestra dirección pública, los paquetes los paquetes dirigidos a nuestro router se enruten a una IP específica al interior de nuestra red. ¿Qué nos dice aquí la documentación? En un router inalámbrico se busca una página como la página de estado que se muestra en la figura, encontrará la información de asignación de direcciones IPv4 que el router utiliza para enviar datos a Internet. Observe que la dirección IPv4 209.165.201.11 es una red diferente a la red 10.10.10.1 asignada a la interfaz LAN del router. A todos los dispositivos en la LAN del router se le asignan direcciones con el prefijo 10.10.10.10. La dirección 209.165.201.11 es públicamente enrutable en Internet. Cualquier dirección con el 10 en el primer octeto es una dirección IP privada y no puede enrutar en Internet. Por lo tanto, el router utiliza un protocolo llamado traducción de direcciones de red NAT para convertir las direcciones IP V4 privadas en direcciones enrutables en Internet. Bueno, ¿a qué? Hay dos procesos, o el PAD, que es el reenvío de puertos. Ah, ok, vale. Aquí en esta versión lo dividieron. El PAD, que también es una forma de NAT, que se conoce como reenvío de puertos, hace eso que les estaba diciendo. Nos permite hacer NAT, al final en el fondo es NAT, o traducción de direcciones, pero basado en puerto, para permitirnos que desde Internet podamos acceder a servicios que tenemos en nuestra red interna. Y el NAT originalmente es la funcionalidad que tiene un router de compartir o arrendar o prestar su dirección IP pública a los equipos que necesitan comunicarse con Internet. Cuando vimos IPv4, si recuerdan, vimos que uno de los problemas de IPv4 era de uno de los problemas de hacer traducción de direcciones era la conectividad extremo a extremo. Recuerden que hablamos de segmentos de direcciones privados y segmentos de direcciones públicos. Los segmentos públicos son enrutables en Internet y los segmentos privados no. Por ende, cuando nosotros intentamos comunicar un equipo con dirección privada a Internet, necesitamos hacer NAT. En IPv4 necesitamos hacer NAT. ¿Para qué? Para que los paquetes, cuando atraviesen nuestro router, no vayan con dirección de origen, nuestra dirección privada, sino con dirección de origen, la dirección pública del router. ¿Listo? Eso lo vamos a ver en enrutamiento, lo vamos a mirar un poco más claro. Entonces, en este caso, este NAT IPv4 se refiere solo a eso, a que el router coge los paquetes que recibe desde la red privada que van hacia la red pública y les cambia la dirección IP de origen por la suya propia pública y envía los paquetes a Internet con esa dirección pública. Calidad de servicio. Esta es otra característica que prestan este tipo de router. Muchos routers inalámbricos tienen una opción para configurar la calidad de servicio, QoS, por Quality of Service. Al configurar QoS puede garantizar que cierto tipo de tráfico, como la voz y el video, tengan prioridad sobre el tráfico que no es sensible a retraso, como el correo electrónico, la navegación web. En algunos routers inalámbricos también se puede priorizar el tráfico en puertos específicos. La figura es un boceto simplificado de una interfaz QoS basada en una GUI Netgear, en una GUI de Netgear. GUI es básicamente una interfaz gráfica de usuario y Netgear es una marca de equipos de red. Por lo general encontrará la configuración de calidad de servicio en los menús avanzados. Si tiene un router inalámbrico disponible, investigue las configuraciones de QoS. A veces es posible que se enumeren bajo control de ancho de banda o algo similar. Consulte la documentación del router inalámbrico o busque configuraciones de QoS en Internet para la marca y el modelo de su router. Reenvío de puertos. Esto es otra forma de NAT, el que les decía. Incluso se le conoce PAT o Port Address Translation. Los routers inalámbricos comúnmente se pueden utilizar para bloquear puertos TCP y UDP a fin de impedir el acceso no autorizado entrante o saliente de una LAN. No obstante, existen situaciones en las que se deben abrir puertos específicos para que determinados programas y aplicaciones puedan comunicarse con dispositivos de otras redes. El reenvío de puerto es un método basado en reglas que permite dirigir el tráfico entre dispositivos de redes separadas. Una vez que el tráfico llega al router, este determina si debe reenviar el tráfico a determinado dispositivo según el número de puerto. Bueno, básicamente aquí, ¿qué vamos a tener? Vamos a tener el puerto externo, es decir, el puerto al que nos van a contactar desde Internet. Supongamos, si lo que tenemos a nuestro interior es una cámara web una cámara IP que trabaja con una página web, el puerto podría ser el 80, el 443 o, o el 8080 o el 8000, por ejemplo, podría ser el puerto. Internal port. Si lo que estamos exponiendo es un servidor web, ¿cuál es el puerto en el que ese servidor web internamente en nuestra red funciona? Ahora, esto nos puede permitir cosas interesantes. Por ejemplo, supongamos que nosotros tenemos 10 cámaras IP y estas 10 cámaras todas se escuchan en el mismo puerto, en el puerto 80, pero tienen dirección IP lógicamente diferente al interior de nuestra red. Pero ¿qué pasa? Nosotros tenemos una sola dirección pública, no tenemos 10. Entonces, ¿qué podemos hacer en este evento de configuración? Decir que el puerto 80 lo vamos a redirigir al puerto 80 interno, que sería el de nuestra primera cámara. Luego podemos decir puerto 81 lo vamos a dirigir al puerto interno 80, pero de otra dirección IP interna. El puerto 82 al mismo puerto 80, pero de otra dirección es interna. Y así, desde Internet podrían contactar nuestras cámaras o podríamos contactar nuestras cámaras con nuestra IP pública, dos puntos, puerto 80, la primera cámara, dos puntos, puerto 81, la segunda, 82, la tercera, y así sucesivamente. Pero internamente o en la vida o en la realidad de nuestra red, todas las cámaras estarían configuradas en el puerto 80, por ejemplo. Entonces, ¿qué es lo que especificamos? El puerto externo, el puerto interno o el puerto real en el que escucha nuestro dispositivo o nuestro servicio, el protocolo, si es un protocolo TCP, es UDP o es ambos protocolos, es decir, no nos interesa cuál, filtrarlo por tipo, sino únicamente el puerto. Y aquí a la dirección IP interna a la que vamos a redirigir ese tráfico que viene de Internet. Aquí estamos diciendo, por ejemplo, que todo lo que venga desde Internet por el puerto 80 lo dirijamos a la IP interna 10.10.10.50 también en el puerto 80, siempre y cuando el protocolo sea TCP. Y aquí lo tenemos habilitado con este checkbox. Esto que tenemos aquí es para nosotros colocar el nombre que le queremos dar al servicio. En el ejemplo que les decía ahorita, aquí podríamos colocar cámara 1, cámara 2, cámara 3. ¿Esto para qué? Para nosotros. no va a tener en realidad un efecto en funcionamiento de la red, sino para cuando nosotros volvamos aquí sepamos por qué colocamos esas líneas. Y estas que están aquí arriba, como ven, tienen unos desplegables aquí. Aquí en estos desplegables generalmente vamos a encontrar los servicios más comunes. Servidor web, servidor de correo, servidor de tiempo, etcétera, etcétera. Servidor FTP, servidor SSH, lo vamos a encontrar aquí. Y con desplegar, él nos va a autorrellenar el tema de los puertos y el protocolo. Y nosotros vamos a tener la necesidad únicamente de especificar la dirección IP y habilitarlo. Listo, hasta ahí, ¿vamos claros?
Sí, sí.
Ok, perfecto. Viene un packet tracer, pero vamos a saltarlo por ahora. Vamos a mirar la configuración de una WLAN básica en el WLC. WLC, si leyeron la documentación anterior, recuerden, configuración de sitios remotos, sí, configuración W. Recuerden que son los controladores de redes inalámbricas o controladores de access point o wireless LAN controller. Vamos a mirar el video de documentación.
Hello everyone, we are here to configure a basic wireless local area network on our Cisco Wireless LAN Controller. This is great. The Cisco Wireless LAN Controller, or WLC, is an amazing box that allows you to have a centralized location for configuring multiple access points and deploying multiple wireless local area networks. So let's take a look at our topology. We've got a Cisco Wireless LAN Controller off of switch 1. We have a trunk connection to carry multiple VLANs. Why would we want multiple VLANs between the switch and a wireless LAN controller? Because we're going to have one VLAN segmenting our management network. The management network is how we're going to configure the wireless LAN controller, as well as how we will communicate with our Cisco access points. Secondly, we need another network which is going to connect the user traffic from the access points to the wireless LAN controller. And this is the users on the network, their traffic. So we will see these trunk connections in between our switch and the wireless LAN controller, and then even switch into our access points to allow multiple networks to exist and be segmented on those cables. We then have router R1 over here on the left side, which also has a trunk connection, because router R1 is going to be doing inter-VLAN routing and routing between multiple VLANs, which are networks, between itself down to the rest of the topology. Also, if we take a close look, we'll see there's going to be a wireless client connected off of access point 1. Access point 1 has a link with PoE marked on it. That is power over Ethernet. Access point 1 is being powered by the switch 1 itself on port FA01. We're going to get started here. We're going to be using PCB on VLAN 1, the management network, to communicate with the wireless LAN controller and to configure it using a GUI. Let's get started. Here on PCB, we've opened a web browser, and we've targeted the 192.168.200.254, which is the management IP address of the wireless LAN controller. We are crossing the switch from PCB on VLAN 1 and connecting with this wireless LAN controller so we can configure it on the management network. Since we've accessed the control already on this web page, we're going to click Login, and we'll be asked for credentials. With the credentials, we're going to have a username of admin, and then we're going to have a password of Cisco123 with a capital C. I'll click Sign In, and we'll successfully authenticate, and here is our main splash page on the Cisco Wireless LAN controller. Right now you can see that we have no wireless networks deployed. We've configured 0 wireless networks, so any access points that are joined with this controller, they have no wireless networks to share with users. We can see that one access point has joined, that is the Cisco access point of AP1 sitting on that topology screen. At this time we have 0 active clients. Nobody has joined our wireless networks because we don't have any wireless networks. So let's make one. Let's create a basic wireless local area network. So to get started, I'm going to click on Advanced. We're jumping right in. When I click on Advanced, we're going to get an overview screen of my Cisco Wireless LAN controller. Here it is. You can see that we have one port plugged in, just one. That one green physical port has multiple networks because of our VLANs. We have VLAN 1, which is for management, which we're using right now on this green port. And we have VLAN 5, which is going to be for user data traffic, also on this green port. That is done through what are called VLAN interfaces. VLAN 1 has its own VLAN interface, and VLAN 5 has its own VLAN interface. Top wireless local area networks. It's empty. We've got none right here. So let's get started and make one. I'll go ahead and click on wireless local area networks. Inside of here, there's none listed. So with a drop-down set of create new, we will click go and let's make one. For the profile name, I'd like to name it something like wireless underscore LAN. And for the actual wireless SSID that the users will see, I want to keep it the same, wireless underscore LAN. The ID is for me to keep myself organized. I'll leave it at the original ID of 1. When I click apply, we are not done. We have just begun. After it loads, we will see here that we have many settings to choose from for our wireless underscore LAN profile. We can see this is a wireless local area network. The SSID of what the users will see. We should probably turn on this wireless. That's the enabled checkbox. Let's turn on the wireless so the users can connect. We have something called interface group. Right now it's set to management. That is the management network. I don't want users connecting to the SSID of wireless underscore LAN and jumping on the management network where they can access and configure the controller as well as the access points. Instead, we'll select the other network that's deployed, which is user underscore WLAN. This would be the user traffic, which is kept separate from the management traffic. That would be the equivalent of VLAN 5. We're not done yet. Let's go into the security tab and actually put a wireless password on that users will have to use in order to get on the network. We'll leave the default security of WPA and WPA2. We will leave WPA2 policy with AES. That's beautiful. But for the authentication key, I'm going to deselect 802.1x, and I want to use pre-shared key, which is PSK. I'll checkmark PSK, and it's going to ask me what password will you have the users type in. And for me, that's...
Les pauso el video porque en el laboratorio Packet Tracer que vamos a hacer, esto es uno de los puntos que más problemas da, porque se nos olvida deshabilitar el 802.1x y habilitar el PSK. Cuando esto pasa, aquí estamos exigiendo unas normas de seguridad diferentes que escapan el alcance de este curso. Y lo que ocurre es que nuestro laboratorio no funciona porque los equipos no se conectan. Entonces, tengan este pedacito bastante en cuenta, ¿vale?
Cisco 123 with a capital C. That's what the users will need to enter in order to gain access to my wireless. I'll click apply because we are done at this time for a basic wireless local area network. And then we're going to go back to the main home screen and verify that there is a wireless network, that users can see it, and that maybe a client has connected. So I'll click on home in the top right corner. And where before we had 0 wireless networks, now we have 1. Where there was 0 active clients, there is now 1. I can click on that active client and we can get more info about it. I can see the client's MAC address. The client has an IP address of 5.2, which is on the user network. Management network was 200. The user network is network 5.0. The client joined on the user network, and they joined on access point 1 using my WLAN profile of wireless underscore LAN on the wireless network name of wireless underscore LAN that the user saw. We have successful connectivity by deploying network settings and wireless settings on a controller and having the controller share it with the access points.
Listo, este sí cubre todo todo este temario, lo cubre el video. Entonces vamos a mirar cómo crear una red Enterprise en con WLC. A ver, configuración, ok. Configuración de una red Enterprise y vamos a mirar el video.
Hello everyone, we are here to do some management with our Cisco wireless LAN controller. This management is about SNMP and Radius. Why do we use these? Well, let's start with SNMP. SNMP is Simple Network Management Protocol. We're going to configure our wireless LAN controller to use SNMP in order to forward log messages, known as SNMP traps, to PCA, which will be acting as an SNMP server. This allows us to have a centralized place, which is PCA here, in order to receive messages from network devices and what's happening, as well as pre-configured events. We'll configure that on the wireless LAN controller to send those messages to PCA. Setting up an SNMP server on PCA is outside of the scope of this lab. We have already configured it. It's running in the background. Besides SNMP, we'll also be deploying Radius. That's Remote Authentication Dial-In User Service. This allows us to use authentication and to verify credentials. How is this going to work? Well, instead of having every wireless client sharing the same pre-shared key of Cisco123 as their wireless password, what if each wireless user had their own unique username password combo to gain access to the wireless? Well, they can. We're going to configure the wireless LAN controller to communicate with a Radius server, which will be PCA. PCA will be the centralized location that we will store our users' usernames and password combinations. As our users try to connect to the wireless network on access point 1, they'll be asked for a username password combo. As they type it in, access point 1 will communicate with the wireless LAN controller, and the wireless LAN controller will verify those usernames and passwords are correct with the Radius server. This is awesome. So let's deploy these settings on wireless LAN controller, and this wireless LAN controller is going to be referring to the 172.16.1.0 network where that Radius server resides. The SNMP server is there as well, and the specific IP address of PCA ends with the .254. So let's configure our wireless LAN controller to communicate with both SNMP to send those SNMP trap messages, as well as Radius to do successful authentication on behalf of our wireless clients. Let's get started. So we're here on our Cisco wireless LAN controller. We're on the main Splash homepage, and we're going to go into Advanced. Inside of Advanced, we're going to jump straight over to Management, and inside of Management, we'll be able to find the settings to deploy SNMP. On the left side, you can see a couple different management services that we can set up. We're going to focus on SNMP at this time. When I click on SNMP, we'll select Trap Receivers. We're going to inform our Cisco wireless LAN controller of the IP address of our SNMP server running on PCA. To do that, I'll click New, and then I can type in the community name that we will use, CCNA V7. Then I'll type in the IP address of PCA, which is running as the SNMP server. And now when I click Apply, this allows my wireless LAN controller to send SNMP trap messages over to PCA, which will then be collecting them. Now, besides SNMP, we'd also like to deploy some security authentication protocol here, and that's going to be Radius. We want to use the Radius protocol in order to have our users' usernames and password combos be sent over and verified on PCA running as a Radius server. That'll be under Security. We will find Radius, and inside of Radius, we will go to Authentication. Now, we have the section for Radius Authentication Servers, and it is blank down below. So let's click New, and we will create a new entry for a Radius Authentication Server. Server IP address is again PCA. That's 172.16.1.254. The shared secret is a secret key that must match on both the Radius server, PCA, and us for the wireless LAN controller. The shared secret allows the Radius server to be able to successfully verify that the wireless LAN controller should be sending username and password combinations against its database on PCA. For that, it has to be the same on both sides, which is testing 1, 2, 3. And then we type it in twice just to make sure it's correct. Down below, we can leave the default settings here for our Radius authentication server. We've got the IP address, we've got the shared secret key, and I can click Apply. It is important for us to verify that the Cisco wireless LAN controller can successfully reach the Radius server in order to send these requests of credentials against it. I can scroll over to the side, and here's a little blue drop down, and I can click on ping. And this will send an ICMP message from the wireless LAN controller over to the server at 172.16.1.254, which is PCA. We've sent 3, we've received 3, we've got 100% success. So at this time, our wireless LAN controller can send SNMP trap messages over to the SNMP server on PCA, as well as our wireless LAN controller can send username, password combinations using Radius from the wireless LAN controller over to PCA to verify users' credentials before they are allowed to join the wireless network.
Este video continuamos ahí en el anterior tuvimos radio CCNMP. Ahora vamos a mirar cómo configurar una VLAN para una nueva WLAN.
Hello everyone, we are here to deploy a virtual interface on our wireless LAN controller. But why are we doing it? Well, what it comes down to is every single wireless local area network that we deploy using our wireless LAN controller, those wireless local area networks need their own virtual interface. A virtual interface would be an interface VLAN. But first, let's take a quick peek at the physical view of our wireless LAN controller. We have 5 ports for data traffic, the blue one followed by the 4 yellow. Each of these physical ports can be configured to support multiple wireless local area networks. It would be done by us taking our virtual interfaces that we deploy, and we'd map that virtual interface to be used by physical ports. And these physical ports can even be bundled or aggregated to create larger high bandwidth links. So let's take a look at our topology again, and then we'll get started in the config. So in our topology, what you'll see is we're going to have VLAN 5. And VLAN 5 is going to be a data VLAN, which is going to be mapped to a wireless local area network that's in use on our wireless LAN controller. Then that VLAN 5 network will be able to be routed by our router R1, which is going to have IP address 192.168.5.1 on it. As users join the wireless network that's associated with interface VLAN 5, those users will be placed on the VLAN 5 network. So let's get started in deploying this. So it's time for us to configure our wireless LAN controller with the new interface VLAN so we can have a VLAN 5 network up and running. So to get started, I'm going to go into my advanced button here, and inside of advanced, we're going to go over to controller. And when I get into controller, we're going to go to the interfaces section. So when I click on interfaces, we'll get a list of all of the interfaces running inside of my wireless LAN controller. Right now, we're configuring the controller on the management interface at 200.254. I want to create a new virtual interface for VLAN 5 so I can have user data move through a VLAN 5 network with a new wireless local area network. So to get started, I'll scroll over to the right. I'm going to click on New for a new interface. It asks me for an interface name. I'm going to keep this simple. I'm going to call it VLAN 5 underscore user data. And it asks me for the VLAN ID number, which will be 5. When I click apply, we're not done. We get a lot of options that'll pop up. So now I need to fill in some information. One of the first things I need to set is the port number. For the port number, this is going to be the physical port on my wireless LAN controller. We're using port 1 out of our 5 ports. Also, it wants an IP address, and this is going to be the IP address of the wireless LAN controller on this network. If we go back to our topology, we'll see that we should have the 5.254 IP address on the wireless LAN controller, and the router will be using 192.168.5.1. So on the wireless LAN controller, I will put in the IP address of 192.168.5.254. That net mask or subnet mask is a /24, which is a class C. The gateway is going to be the router's IP address, which is the exit point for the VLAN 5 network. So I'll put in 5.1 for the router. I don't have IPv6 addressing info, but as clients do come in on the wireless network and join onto network 5, this network should have a DHCP server, and that'll be router R1. This can provide DHCP services for the local network. Now, a wireless LAN controller can be a DHCP server, but there's only a specific reason for that, and that's usually to give IP addresses to the access points themselves, and only the access points. That's for management purposes. So there's nothing else for me to configure on this screen. We are good to go to hit apply, and I'll do that in the top right corner. Get a little pop-up for a warning. We'll click OK, and our VLAN 5 user data interface is now deployed on our wireless LAN controller. And this is that virtual interface. So I'm not completely done yet, because the virtual interface exists, but now I need to map it to a wireless local area network. So I'm going to go into my wireless LANs, and inside of here I'll find my user data Wi-Fi. I'll click on that wireless, which is the number 2 ID, and inside of here there's a drop down for interface and interface group. Right now this is putting users on the management network, but if I click that drop down, now I can select that new interface VLAN 5 and have it mapped to the user data Wi-Fi. As my users join the user data Wi-Fi wireless network, they'll be put on the VLAN 5 network. And apply makes it happen.
¿Hasta ahí tenemos alguna duda? Bueno,
No, señor.
ok.
Hello everyone, I hope you're ready. We are here to deploy a DHCP scope on the wireless LAN controller. DHCP? I thought that was on the router. Well, we're going to deploy a DHCP scope, which is very similar to a DHCP pool, but we're going to do this on the wireless LAN controller. And we're going to do this because we want to provide management IP addressing to management devices using DHCP, all controlled from the WLC. Now, this is a specific use here. We're going to provide IP addressing to management devices. We're talking access points that are joining our wireless LAN controller, and we're talking possibly a management PC that would be used to configure the wireless LAN controller. So let's get started. Just a quick reminder here as we get started in configuring the wireless LAN controller, but we are going to be configuring a DHCP scope, not for providing hundreds of users IP addressing. We're creating a DHCP scope to provide dynamic addressing to management devices on the management network, which includes a management machine, as well as our lightweight access points that'll be joining with our controller. So let's get started. We're going to go into the advanced section first. When I click on advanced, we'll have our new screen come up. And inside of this area, we're going to go into controller. Within controller, on the left side, we're going to look for the internal DHCP server. And again, this is very similar to a DHCP pool on a router. DHCP scope looks just like a DHCP pool. I'll click on DHCP scope, and we'll see we're going to have an address pool, lease time, and some other info. Let's get started by clicking new, and you'll give ourselves a scope name, such as management_IPs. That's a beautiful name for management purposes. With the name of management IPs, I can click on that name I've created. It'll load a new screen for me to fill out all the information regarding my DHCP scope. We're going to begin with the pool start address, and this is going to be the first IP address that I'm going to have my DHCP service provide on this management subnet. And that'll be 192.168.200.220. This is the first IP address I'd like to provide on this management network by using this DHCP scope. And the last IP address would be the pool end address. I'll make that 192.168.200.240. In all, I'll be providing up to 20 IP addresses using this management scope. It allows me to deploy up to 20 lightweight access points, or a dozen, and then some other IPs for management purposes. The network itself is 192.168.200.0, and the subnet mask for this management network is all 255s ending with the .0. the least time we can leave at the default. The default router is the exit point for the network. That is not us on 200.254. We're a controller. The exit point is going to be the router's IP address, which is router R1, which is 192.168.200.1. Our scope is good. We need to just enable this. So we'll change the status from disabled to enabled, and we can go ahead and click apply. Our scope is now created on the wireless LAN controller, and now we can verify it's ready to be allocated to a new wireless local area network.
Listo, y continuamos con el siguiente video. Configurar una red inalámbrica WLAN WPA2 Enterprise.
Hello everyone, it is time to hook a company employee to a company data network using wireless. So in this scenario, we've got a company employee on a laptop, and they're going to be connecting to a wireless network that we're about to build. This wireless network is going to use WPA2 with Enterprise. What that means is we're going to go on the wireless LAN controller, configure a new wireless network to be deployed to our access point, and we're going to utilize Enterprise with authentication. That employee is going to need a username and password combo to get on the wireless network, and our wireless LAN controller is going to take those credentials that are submitted by the user, and they're going to forward them over to PCA, which is running as our Radius server, and it'll get a response back and either allow or disallow that company employee on the company network. So let's get started in configuring the wireless LAN controller. So here we are on the dashboard of our wireless LAN controller. We're going to start by clicking on Advanced. Inside of Advanced, we're going to go to our section of Wireless Local Area Networks, and we're going to create a new one. So we have the drop-down set to create new. We'll go ahead and click on Go, and we're going to name this. The profile will be Company Name. Our SSID, the wireless network name that our users will see, will also be Company Name. And that ID value, we can leave it at 2. I'll click Apply, and now we have a lot more settings to look at. We'll enable this wireless network, and we're going to make sure that the interface is using our company data network, which is our VLAN 5. That's where the data is. VLAN 1 is our management network. We're leaving that alone. We can leave the rest of these settings at their default, and now we go to security. Inside of security, we see that we're allowing WPA and WPA2, but down below, we have 802.1x set by default. This is what we're going to utilize and use this in order to have our devices that connect to the wireless be requested for username password authentication. But we need to have those requests forwarded somewhere, and that's going to be our tab for the AAA servers. When I click on AAA servers, you'll see that no servers are currently selected. In a previous video, we actually identified a Radius server inside of our wireless LAN controller configuration. So in the server 1 dropdown, I can actually scroll down and I can select a previously identified Radius server. The port of 1812 is set, as well as the IP address, and this is the IP of PCA, which is running as the Radius server. We're not using any accounting feature, so we can leave that at the default of none. At this time, I can now click Apply, and now the company name profile has been deployed on a wireless LAN controller, and this wireless network will be shared out to our access point. Let's do some verification. So let's go ahead and click back, and we should be able to see this wireless profile now created. And here you can see it. Wireless LAN ID is 2. Remember that. It's a type of wireless local area network. The profile name we created was company name, and the wireless LAN SSID, which is the wireless name the users will see, is company name. We have this thing enabled, and we're using WPA2 with 802.1x for our authentication. That authentication being requesting usernames and password combos as our users connect to the wireless. But let's verify that our wireless LAN controller can actually take a username and password combo that it'll receive from a PC, forward it over to our Radius server, and have the Radius server respond back with a successful authentication message. To do that, we're going to the console port of our wireless LAN controller. So here we are on the console port of our Cisco wireless LAN controller, and we're going to use two different commands here in order to verify that our wireless LAN controller itself can take a username password combo, throw it against the Radius server, and have the Radius server respond back with a successful authentication message. So to get started, we're going to use the command test followed by AAA, and we're going to use Radius. The username command followed by the username of Bob. Because you know what? One of our wireless clients might have a username of Bob. And followed with the command password. And Bob's password is probably hello. That's a nice combo. And then we're going to specify the wireless LAN ID. And this was that ID value we saw in the GUI, which was an ID of 2. And this was the profile company name with the wireless SSID company name. And using WPA2 with our 802.1x authentication. So we're going to shoot this off to our Radius server. And we should get a response back. And let's take a look at seeing that response. To see the response, we're going to use the command test AAA followed by show radius. And let's see what the server sent us back. Well, our server sent us back an authentication response result code success. We've successfully reached out to the Radius server from our wireless LAN controller with the credentials of Bob Hello, and the Radius server says that user is good to connect. This is awesome. Enjoy WPA2 with Enterprise targeting a Radius server on the wireless LAN controller.
Listo, vamos a ver cuál sigue. Bueno, señores, ahora sí nos toca hacer estos dos packet tracer que tenemos, el packet tracer 13110 y el packet tracer 1345. Empecemos por el 1345 y el 13110 me lo envían después, ¿vale? Pero empecemos por el 1345. 1345 solución, perdón, 1345 no. 13312, perdón. 13312. Te los voy a colocar en el grupo de WhatsApp.
Vale, profe.
Chicos, ¿mañana tienen cambio de turno o podemos hacer clase?
Sí, dije, mañana tenemos cambio de turno.
Vale, listo. Yo les iba a decir que los cambiáramos para los jueves, pero ya los jueves tengo otra actividad. Entonces nos tocó seguir así. Igual ya estamos terminando. El otro módulo es todavía más corto. Bueno, chicos, ¿cómo van? ¿Cómo vamos con ese laboratorio? ¿Muy difícil? Ingenieros,
Ahí vamos, profe, ahí vamos.
bueno, vale. Bueno, si no tienen ninguna pregunta, entonces nos desconectamos y nos vemos el siguiente lunes. Recuerden hacer el otro laboratorio también, por favor, ¿vale?
Listo,
Listo,
profe,
bien,
muchas gracias.
gracias.
Bueno, listo pues. Entonces, que tengan un feliz resto de semana.
Gracias.
No hay que descanse.
Ok.